Welcome everybody. This is going to be the last online class for this Engineering 18. Let's finish up this chapter 18, the pictorial drawings, and then we're going to get ready for final next week. Let's look at the overview of the pictorial drawings. Pictorial drawings facilitate communication of technical information during the design process. And three types of drawings. We have oblique, isometrics, and perspective. Oblique drawing is the easiest of the three to draw. In oblique drawing, one surface of the object, usually the front view, is drawn exactly as it would appear in the multi-view drawing. Circles are true circles, and rectangles parallel to the frontal plane are in the true size. Isometric drawings are the most used of the three common pictorial. They're easier to draw than perspective drawing, and they illustrate objects almost as well as perspective drawing. Isometric drawings use three axes, sometimes called principal edges, at 120 degrees in each other. And advantages of oblique drawings, especially starting with the front view, cylinder are round, angles are in the true size, and irregular curves are not distorted. If you look at the oblique drawing here, and one surface of the object is drawn exactly like it would be in the multi-view. This is usually the front view. The Z angles is usually drawn at 30 degrees or 45 degrees. Circle appear a true shape in the front view and as ellipses in the other view. Measurements are taken from the multi-view drawing. X, Y dimension match those in front view and Z dimension. The depth is your Z dimension are laid out parallel to the third axis. They are most common pictorial drawings. All drawings are distorted. The angles are drawn 120 degrees from each other. Circles appear as ellipses in all the view, do not show the hidden line. So if you look at this few different angle of this oblique drawing, and you can, if you want to start starting point here, then you would draw 120 degrees on these three axes. So if you want to start from this point, do the same thing, put the two template here, and from here, starting point, one is going to be Y, and this is going to be your depth, and then this is your width. So very common three axes, X, Y, and Z. If you want the oblique drawing to be starting point at this location, then you do the same thing. From here, you have your Y is going down, and your depth is going to. So you have X, you have Y, X, and Z. This is going to be your depth. So same thing, starting point here, then your Y, and then your X, and your Z. So same thing, doesn't matter where is your starting point. Start from the point, and your Y point, X point, and your Z point is your depth, the depth of the object. When you look at this this example here, I'm gonna show you how to draw an isometric drawing. Given the multi-view projection, given top view and the front view and the right side view, and is given the width and the height and also the depth of the object, and then you're gonna locate that starting point. If you want to locate that starting point right here, then you're gonna draw 120 degrees, divide that into three angles. So you have, if this is gonna be your Y, X, and this is gonna be your Z. We call all this X, Y, Z as your principal edges. And now we can transfer that dimension W, H, and the depth into a basic shape. So this is a basic shape with your height, depth, and your width at 30 degrees twisted. So then Now you can transfer the rest of the dimension from your multi-view projection onto this basic shape, and then you're gonna connect all this point, and then lightly erase the all this line to show the final product with a completed isometric view. And this is another good example to how to center within the work area. So given that multi-view drawing, again with given the width, given the height, given the depth, and this is your work area, this is your paper size, whatever the paper size could be 8.5 by 11 or 22 by 36 or whatever the size you want to be, and you want to first thing to center within your work area. In order to draw the isometric, you're gonna have to center the isometric view within your work area. So start with the center of the work area by measuring halfway between the width, halfway between the length. Establish that center of the work area, and then now you want to start with a point here. So to start a point here, now you're gonna have to go north half of this height, and then you're gonna go to southwest direction to establish that point, and then you go to southeast direction to come back to the center of the work area. From here, this dimension here, this distance here is going to be 1/2 of the d. Whatever the d here is 1/2 of the d, 1/2 of the h, 1/2 of the width. With that 1/2 of this width, height, and d, now you're gonna come up with the basic shape. So your basic shape is gonna start from your starting point. This is your starting point, and with a starting point, you're gonna start putting this basic shape with a basic shape, and then you're gonna transfer all this dimension onto the basic shape, and then erase some of this erase the basic shape that is not needed on the completed isometric drawing. So when you develop the isometric drawing as before, first the basic shape or the box with dimension W, D, and H, and then the offset measurement A, B, and C parallel or perpendicular to the frontal, top, or the profile planes. So basically you're gonna start with basic shape and then find out where your starting point is. From the starting point, you're gonna transfer all this basic shape, transfer all this dimension onto the basic shape, and then try to and that will be the center. This shape here will be the center within the work area. So you want to note that your x here and x here should be equal distance, y and y here should be equal distance. Offset measurement are used to locate one feature in relationship to another, we have a non-isometric line are not parallel or perpendicular to any of these three principal planes in the multi-view drawing. Use a boxing techniques to draw this type of line. If the line is not parallel or perpendicular to any of the three principal edges in the isometric drawing, it is a non-isometric line. Let's go through all these three different method here. We have an offset measurement, non-isometric line, or we use a boxing techniques to draw this type of line. So multi-view projection, and if you look at that, you can see we have given this multi-view projection with the width, depth, height, and the C dimension and A dimension here. And you're going to start with a basic shape. With a basic shape, given this A, and now you're going to transfer BB, BB, and then the C is going to be the height, and this is your offset dimension. Offset dimension, and now once you have all this, transfer this onto your basic shape. Now you can connect this dot and erase some of this construction line, and this is to show the complete pictorial drawing with offset measurement. So for non-isometric line, when we say non-isometric line, that means this line here, we have an oblique non-isometric line. It's not the true length. When we have this kind of situation, you basically doing the same thing. You have all this, given all this multi-view projection, and with a basic shape, you're gonna draw the width and the depth and the height of the basic shape, and then you're gonna measure the dimension where your x-axis is, your x-axis, measure the dimension x-axis there, and then you have a dimension y-y, measure the dimension y-y there, and then you're going to connect this point to show that non-isometric line. And then when you finish, basically you just erase the construction line to show the complete pictorial drawing. For the box by boxing construction, so there are 3 different methods, and the first method is to show you that first method is the one that we're going to use the offset measurement, which is you're going to have to use the offset, all this distance here, transfer the distance onto the basic shape, and then erase the construction line to get you the object. And the second method is to non-isometric line when you have inclined surfaces, and this is your non-isometric line. With that situation, you do the same thing, transfer this dimension to get this non-isometric lines. This is a method that we're going to be doing to use the box construction. So the box construction, the hidden line are not used in the isometric drawing unless needed to show an important feature that otherwise would not be seen. Try to orient object so hidden line are not needed, not only the isometric drawing, but also in the pictorials. Some objects have lines that don't line up with the isometric axis, so use a box or basic shape to offset to establish offset dimension for drawing an object. So for this particular case, we have this given multi-view, and given the dimension from here, you're going to measure distance A, B, C, D, and you also get given this, and then you're going to measure the W, and then same idea, complete draw the basic shape, and the basic shape with a base. So this base is going to be the width, whatever the width of this shape here. Width, you transfer the width, your distance, your depth, the depth, and the height of the object, and the height. Once you establish that basic shape, now you're going to have to find out what is your dimension A. So dimension A, as you can see, dimension A pi. This is A pi, A. So A from the point, the vertex of the that pyramid, you're gonna go from here A to, this is your A to your H of the box, and then you have A pi, C, you're gonna get a C, and then B, get the B dimension, and then you will just connect these dots. Once you connected these dots, you may just lightly erase this construction line to show the isometric view completed. So for the drawing an isometric curve, offset distances, and the depth, to draw a isometric curve, this curve is given this curve, and you're going to divide them into equal spaces, even spaces from this given multi-view, and then you're gonna draw the even spaces parallel to the base. For this case, we're gonna divide them into 6 equal spaces. This is you got the height here, you got the width, and you have the depth of the object. So from here, you're gonna transfer this distance here, equal spaces, to this object, and then from here you're gonna measure at from 30 degrees. Always the oblique drawing, set it up at 30 degrees, 45 degrees. At 30 degrees, all this has to be 30 degrees and has to be parallel with the base here. And then you would just measure what the D is. The depth of this object is, let's say, 1 inch. You're gonna have to measure 1 inch from this line, and then you would just use your French curve to connect them. Same thing applied to this isometric grid layout. By doing so, you are given the multi-view of this isometric curve, and to transfer this isometric curve onto Pictorial, the oblique drawing. And the one thing you want to know is to determine what the W is, what the height is, and what the depth is. So you're gonna come up with a basic shape first. So this is a basic shape with a W, height, and the depth. And then you're gonna have to use your irregular curve, and then you know from here 1 and 2 square. So you know 2 squares here. From that point, draw the curve to here, and then continue the same process from here. Make another curve, smooth it out, and then from here, and then continue on and use your French curve to, or you can establish all this dot first before you use a irregular curve. It would make your life a little bit easier. So once you use a irregular curve and finish all that curve, and lightly erase all this construction line, and that's how the completed isometric view is going to look like here. And isometric drawing, irregular shape are drawn by dividing them into a series of convenient section or layout grid. Use a template for circle and arc. So I'm going to end this video here, and we're going to continue on in the next video to talk about the irregular shape object and how we're going to use the circle or ellipse template.